So hello, good morning. This is Jörg Mühlenhoff speaking from Climate Action Network Europe, CAN Europe. Good morning to the participants that are step by step arriving. You are right here. It's a few minutes past 10. This is the introductory session of our webinar under the PAC scenario workshop. We will start with the first introductory session for those who are interested in learning the basics about our Paris Agreement compatible energy scenario. Then after 30 minutes, around 10:30, we start with the main PAC workshop when another part of the participants will arrive and join us. So I hope that you can all see me, see the presentation on your screen. I'm not alone here. Luckily, I have with me my colleagues, Jonathan Bonadio from the European Environmental Bureau, who will do the moderation today with me, and my colleague Martina Miglioranza from EEB, sorry for the pronunciation, who is kind of DJing today to make sure everything technically works well. So we are happy to have you here, and I leave the floor to my colleague Jonathan to give you some housekeeping rules.
So good morning, everyone. I'm Jonathan Bonadio. Let me, in the name of the PAC project team, say a big good morning, hello to everyone, and thanks for joining us. I will start for those who don't know me yet, I'm Jonathan Bonadio from the European Environmental Bureau, working together with Jörg from CAN Europe on the PAC scenario. A couple of housekeeping rules before we start so that everyone feels comfortable for the next 2 hours, and then we can run smoothly this webinar. So first of all, the very indispensable, you have to grab a warm beverage just to enjoy this session for 2 hours. Then, of course, on the housekeeping, there are a couple of rules to follow. Hello, everyone, indeed. And so they are the following. So I would invite you first to check your name so that your name appears as first name, last name, and organization into brackets. So for this, you have to follow the procedure, which is on the slide. We have to click on participant, then select your name, click on more, and rename using first name, last name, organization. If you have any technical issues for this setting, or if you have any technical logistical issues in general, you can use the chat box. So the chat box is the one that appears on the bottom of your screen with a little comic bubble here, and so you can interact directly with our EEB staff. You can select EEB staff, which is Martina, who would help you on logistics. So please use the chat box for technical question, and don't use the chat box for question on substance and presentation, because you will have the Q&A tool for this. So apparently people told me that the participant button is not visible. So this is a question that is very relevant, although it should have been asked into the chat anyway. But Martina have to make you turn you as panelist, as co-host, so that you are able to change it. So Martina will help you with this. You should be able to see yourself as a co-host in a few minutes, and then you will see indeed the participant icon appear on the bottom of your screen. Yeah, I mean, everyone seems to have same issues. So Martina is going to gradually turn you into participants or co-host, and you will be able to set this in the next minute. So I just ask you a bit of patience with the help of some warm coffee. So a very important thing as well. So the workshop is recorded right now. So I'll ask you to have your biggest smile on the screen. The video would be used, of course, for reporting purposes, and potentially also put on the PAC website eventually in the future. So without further ado, I will leave the floor to Jörg. In the meantime, you should have gradually access to these participants. Please keep us posted. If not, Jörg, the floor is yours, and thanks indeed for your attention.
Thank you very much, Jonathan. So we will now try to guide you through the key findings of our Paris Agreement compatible energy scenario, the PAC scenario. It is a bit packed, but we will try to make sure you get the key numbers within the next roughly 15 minutes. And then we will have also still some time left for your questions with regards to our results. What is so special about this PAC scenario? It is the first civil society-led scenario that shows a pathway towards 65% emission reduction by 2030 in the European Union, towards net zero by 2040 already. And the special thing about it is also that we just didn't have a huge multi-million euro budget to commission highly sophisticated models or research institutes. We did it more or less on our own with our networks, with the members of CAN Europe and the European Environmental Bureau to collect really the wisdom of the crowd, the expertise of our members. We invited experts to a series of workshops that started roughly at the beginning of last year to really just compare the existing state of research with regards to the future energy landscape of Europe. And our starting point, of course, was that we urgently need to act because of the climate crisis. The IPCC report that most of you know with regards to the 1.5 degree target is crucial. That needs to be implemented. That was the starting point from a global perspective. And the United Nations Environmental Programme emission gap report also clearly tells us you have to cut your emissions at least by roughly 7% per year, which translates into 65% emission reduction by 2030. So we tried really to provide a robust, substantial answer. You know that here in Brussels, we often, as NGOs, we hear this sentence from journalists or from policymakers: you NGOs, you have an easy job. You always just ask for higher targets, but you actually never explain how to get there. And now I think to some extent we can fill this gap. We have an answer. We have a pathway, and that is not that we are the first or the only ones to do this. We based our study work on existing reports on science. You see here just a selection of some of those recently published studies that we partly took over or we discussed with the authors, and some of them are also guest speakers later in the second part of this webinar. And they also had a deeper look into our figures, so that was really a kind of mutual exchange and enrichment in this process. I will now just hand over to Jonathan for a short introduction to the methodology of this PAC scenario.
Thanks, Jörg. So the methodology of the PAC scenario has been quite straightforward on the building of this energy system. So the first step of the PAC scenario was to determine what would be the energy demand. So how will we, as European, consume energy in the future for different sectors? So we started with studies with the state of the art in terms of science, but also with connection and discussion with our members, stakeholders, energy experts to determine how our energy demand would evolve in the future. And then, of course, the question is how to match this demand with proper energy supply, sustainable and safe energy supply. So we use the as much as possible the Eurostat methodology to match supply and demand on a yearly basis, so to have sufficient amount of energy to fill the energy demand by 2020 to 2050. Then we checked, of course, against our policy ask, our demands, the targets on greenhouse gases, energy efficiency, and renewables, see if this energy system was actually compatible with the overall ambitions, the overall targets that we set for the future. So you will tell me this is good, but this might not be sufficient, because if energy demand and supply match every year, it doesn't mean that they match every hour. So for this, we had a very helpful analysis, thanks indeed to Eco Institute, that put hourly modeling so that for the electricity system, we were able to prove that this energy mix that we've chosen for the PAC scenario was sufficiently safe and stable. So this is also something very important, and Jörg will tell you a bit more about this analysis afterwards. So on the next slide, what we can see is that our energy demand, without going too much into the details, we are able, in Europe, we could be able to reduce energy demand divided by 2 between now and 2040, 2050. So this is a very important lesson that we have learned, thanks to energy efficiency gains, but also thanks to fuel switching from combustion to electrification for some sectors. We are able to divide this energy demand by 2 with available technologies. The other side of the picture, which is the energy supply on the next slide, is that we will have, of course, to adapt it to the demand, but we have to make it evolve to make it net zero. What does it mean, make it net zero? Phasing out fossils again and again. So fossil gas, fossil oil, and coal need to be phased out respectively by 2035, 2040, sorry, and 2030. And this is how we will explain how we achieve this for the different sectors. So which leaves the room for electrification, which leaves the room a bit also for marginal synthetic and non-fossil gases and fuels. And Jörg will then introduce the specific sectors.
Yeah, we had a deep dive into the different sectors, starting with industry, how do chemicals, steel industry, and so on develop. First of all, the big headline for the industry sector is the circular economy approach, which means, amongst many other things, that we will reduce the material demand of the industry, which then leads also to a drop in the final energy demand of those industry sectors. The remaining industries' energy demand will be covered more and more by renewable electricity, because we can electrify quite some processes, knowing, however, that certain applications, certain processes need high temperature heat. And for those processes, like in the steel industry, renewable hydrogen will have to be introduced. When it comes to the buildings we are living in the residential sector, the big headline is another one. It is the deep renovation wave. The deep renovation wave means that we triple the annual rate of renovated houses amongst the European building stock. From currently 1%, we would renovate in the future up to 3% of the building stock by year. And that will be a deep renovation that cuts the final energy demand massively by up to 2/3 by 2050. And at the same time, this deep renovation wave is the perfect opportunity to replace the existing individual and very inefficient fossil heating systems like gas boilers with either an electric heat pump or with a connection to a district heat network that can then supply other sources of renewable energy to the households. When it comes to the buildings we are working in, the public building service, the tertiary sector, it's the same trend, same headline, same big picture, deep renovation wave with a bit more share of electricity, since, of course, there is the IT sector that demands quite some electricity still in the future. With regards to agriculture, the big headline is a switch from fossil oil products to sustainably sourced biomass that you can use as a byproduct that occurs anyway as waste or residues in agriculture. Plus, again, of course, renewable electricity. Some of those applications like farming machinery will not be electrified. So there is a certain marginal role for bioenergy in this sector. And regarding transport, I leave it to Jonathan again.
So for transport, actually, the picture is extremely simple to understand and extremely complex, of course, to make concrete. I mean, the target of the transport is to phase out a sector which is depending from fossil fuel currently from above 95% to 0 by 2040, which was the challenge of the PAC scenario. We know that this is technically feasible, meaning that the technologies to replace fossil oil mostly are here. But of course, this requires a big systemic change and a swift shift to electrification through electric vehicles, battery electric vehicles, and where not possible for instance, heavy transport, heavy freight, or aviation or maritime freight, then of course envision the possibility to use non-fossil gases such as hydrogen and ammonia. But the big picture indeed is phase out of fossil and therefore electrification, and which give a good transition to the next slide for Europe.
Yeah, you already noticed that in those sectors, the blue slice representing electricity is quite important. You might ask yourself now, what is the electricity mix? If it's solar and wind mainly, can they really take over all these future demands? And yes, of course, uptake of solar and wind is key. We roughly need to double the current electricity generation in the EU until 2050. And it will mainly be done with a multiplication of solar and wind onshore and offshore, which might look really gigantic, but it is, of course, just the mobilization of the cheapest energy sources that we currently have available in Europe. And this future electricity demand has to be covered with regards to additional electric vehicles, with regards to electric heat pumps, electrified processes in industry, and the many electrolyzers that will produce the renewable hydrogen that we need in certain industry and in the aviation and shipping sector. Will an energy system that is based on solar and wind, on variable renewables, depending on the weather, will this system really be stable? What about adequacy? This, of course, is a question that we also looked into with this electricity market modeling that Jonathan already mentioned from Öko Institute under the scientific lead of RGI. This electricity modeling clearly confirmed our vision of the future energy system. It's not only about, in a quantitative way, ramping up massively renewables, it's also a qualitative change because we need more flexibility. There are several flexibility options that can balance or offset sun and wind whenever the sun is not shining and the wind is not blowing. We can assure you the good news is the houses will keep them warm and the lights will not go out. Flexible fossil power plants could be an option in a transitionary period, but you better switch them off as soon as possible to free up the grids for renewables. And anyway, we have to expand the electricity grids, also in particular on the distribution grid level, to allow for a smooth integration of solar and wind and other renewable sources, like also flexible, dispatchable renewables, like flexible biogas, that can jump into the gap whenever the sun is not shining, the wind is not blowing. Then, of course, we as consumers, we will have to become also a bit more flexible. In particular, in the industry, electricity consumption will follow also more interactively price signals or signals from the grid operators to offset and to balance and to ramp up or ramp down your electricity consumption whenever there is an oversupply, for example, during a storm. Last but not least, storage plays a very important role. Not only batteries that can help you throughout the day, the next 1-2 days, maybe on a household level, if you're a solar self-generator. It's also electrolyzers that need to become much more flexible to absorb the excess renewable electricity in certain regions of Europe. So this is the big picture for how the European energy landscape will have to look like to reach 65% greenhouse gas emission reductions by 2030. It's a civil society-led energy vision that is endorsed by all the members of CAN Europe and the European Environmental Bureau, EEB. And it is, of course, only on EU 28 level. It's an aggregated scenario, and to be very transparent, there are of course many elements that we did not look into and that are missing, and we are trying to explain and discuss with you a bit in the second part of this webinar how we might find potential answers, what science tells us, and which avenues there are to continue this very, very enriching grassroots research initiative for the network, by the network. So of course, we cannot say yet how much does it cost. The macroeconomic impacts have not been assessed, and there is no detailed assessment of the non-energy and non-CO2 related emissions. We did not take any detailed assumptions on carbon removals yet. When you look into our technical summary, you can see that, of course, we remain purely on an EU level in a very simplified way. And unfortunately, there are not yet any national PAC scenarios, but this is to be discussed. And we would like to continue the discussion in this direction with you. So now, after 15 minutes of short introduction, we still have roughly 5 to 10 minutes for your questions. And I think there is already a bit, maybe, Jonathan, can I hand over to you for?
Yeah, definitely. So, I mean, first, I have to thank you all for your discipline regarding the housekeeping rules, because I'm checking now the chat and I see that are apparently only housekeeping and logistical question, which is very good indeed. So now, of course, if you have questions on this presentation, I know that some of you are very familiar to this, some of you might be new. So please, I mean, we are here also to reply and to answer all potential questions on this PAC scenario. We will eventually provide you with all the links to the website and to the different parts of the study. Apparently, so yeah, you are free to use the Q&A, and I see that there are no questions on the Q&A. So we'll just be waiting for 1 minute if there are specific questions on the question and answer. Then if
there are questions actually in the chat box, and there is also a message.
There is
feeding the Q&A box. I mean, it's maybe a bit confusing. Zoom is very comfortable in terms of all the functions, but I see there's a question from Toby regarding bioenergy. I will try to briefly touch upon that. Forest biomass, of course, that is an element of the PAC scenario that we discussed intensively during the previous scenario workshops with our members, with experts from this area. Forest biomass is mainly phased out in the energy mix by 2040. And we assume that not only for sustainability reasons, also for efficiency reasons, it's not a good idea just to burn in stoves all the forest biomass. This wood energy could be used in a smarter way, which for us would be in a transitionary period, cogeneration being a kind of backup for district heat networks, but there also we think that forest biomass will disappear, and there will be probably a higher demand for forest biomass as a raw material, be it to replace concrete in the construction sector, be it to serve as a raw material with regards to the chemical industry's demand for fossil oil that partially could be substituted. However, saying this, for the big picture, the demand for biomass, in particular for solid biomass from forests, will decrease by roughly 2/3 in our scenario. So we respected the European Environmental Bureau's burnable carbon paper limitations. That's a more detailed paper that outlines future sustainable biomass potentials in Europe. And we took over these figures as a kind of red line. And of course, as I explained, we will, in the PAC scenario, reach this sustainable level of biomass consumption by the 2030s to ensure that our scenario, of course, would not do any additional harm to biodiversity and to sustainability in the biomass sector. When it comes to the emissions, of course, this is an element that we still would have to explore more in detail. We will see in another presentation from one guest speaker later that we started recently a project with Climate Analytics to look deeper into emission reduction pathways. The question from Samuel on social justice criteria. As I said before, unfortunately, we do not have a proper macroeconomic assessment. We cannot say how these figures translate into households' energy bills. We can roughly estimate what are the savings, what are the total energy costs. These are figures that our guest speakers from Karlsruhe Institute for Technology and Aarhus University will explain later in the last part. I see also a question from Kenneth. The PAC scenario as a living document. How will the scenario development continue from here? Yes, of course, this is just a first overview for you to step into this process and to continue it. You can still, of course, even if you didn't follow the previous workshops, you can jump into this process. All members and other stakeholders, of course, are welcome. We will end the PAC project by December this year. But this workshop actually serves as a kind of starting point for a potential future process. We are exploring currently work strands, future avenues to deepen this research, to disseminate the results, and to really make it work for you on the national level, for our members, so that it really helps your work on the ground. Question from Carlotta. Macroeconomic impacts, yes, in a second stage. And we will have a presentation later from Elisabeth from Karlsruhe Institute for Technology. She will also touch upon macroeconomic effects, same for our guest speaker, Christian von Hirschhausen, later. Emissions from burning biomass, we touched upon that. Okay, the forest biomass, I already extensively touched upon that. We are approaching 10:30. We, I think, need to wrap up. Jonathan, do you see any additional questions? Yes.
Yeah, maybe as a reply to a compilation of questions that have been asked on beyond energy aspects, so social justice, mineral resources, resources in general, etc., macroeconomic. This is indeed elements that we are aware of. These are elements that were not expected in the first in this stage of the PAC scenario, but we are aware of this, and it's also will be part of the discussion of the upcoming session. So please be patient, because this is also something we will discuss the interest of these different topics. I saw also right now a question about space. So this is indeed things that we have under the radar, and we'll be happy to discuss it in the next steps. Now, just for logistics, I see now that gradually you should have access to the Q&A box. So just for the next session, you should be able to ask your question on the Q&A box. So voila, our apologies for this first adjustments, but this should be now set and gradually improving. Thanks indeed, and leave the floor to you for the actual beginning of our fourth PAC scenario workshop.
Yes, and sorry for the confusion with regards to the Q&A box for your question and answers. We will record those. There are a few questions still in the Q&A box. We can try to answer those with the notes that we'll send around as a summary together with the presentations of this workshop. So this will be saved, and we will be able to respond to those few questions in the Q&A box. So let me now say hello again and good morning for a second time for those who only join now at 10:30. We have already behind us half an hour of very quick ride through the key findings of the Paris Agreement compatible scenario that was done by CAN Europe and the European Environmental Bureau together with our members during the last 1.5 years. We now are trying to dig a bit deeper with you into the future of this scenario, how to make it work for you, so that there is an added value also for your work on the national ground, for you as energy experts or researchers who are joining us today. We have roughly 60 registrations, and we see that the number is still increasing. Good morning again. I hand over once more shortly to Jonathan for the technical details for the housekeeping rules for the remaining 1.5 hours.
So good morning for newcomers, the 20 newcomers that we have. A good morning again to everyone else. So the rules remain the same. So a couple of technical updates on this webinar for 1.5 hours on the fourth PAC scenario workshop. So you will be able to ask all the questions under the Q&A box now, hopefully. And you will have also the opportunity, if there is any technical issues, to use the chat box. Apparently the name should be set now, so you should have set your name, or no, the access of the name is no locked. And also for the newcomers, a quick reminder that the whole session would be recorded, and then we will have a bit of the a display of this recording further in our website, hopefully in the future. Voila. So these were for the basic housekeeping rules. Please do not hesitate to also contact EEB staff under the chat box if there is any technical issues, and Martina, who is here, will be able to help you as well. So thanks indeed. We are going to start the fourth scenario workshop officially. So we'll start actually with the participant button has now been disabled. So please, Jörg, on the next slide. We will now start the seminar and the workshop itself. So you should all be set and ready for this 1.5 hours of discussions around the current PAC scenario, and of course, as a teaser, potential future of our work. So thanks indeed. And let's start with a very first overview of what the PAC scenario has been for CAN Europe, and the European Environmental Bureau, EEB, under the next 2 years. So we are now, we had our launch event on the 30th of June. So the PAC scenario is on air. You will have the web links at the end of this presentation. And we have we could be quite happy of the outcome. We have the 250 participants. And also let me use this opportunity to thank all of you who contributed, who participated in a previous workshop, for their help, support, and of course, technical advice. So we have now a 50-page summary and open license data set. So you should have everything handy on the website to help guide you through the findings of the PAC scenario. We had, of course, some broadcasting and media articles. And as we will see in the previous, in the next session, we have a very helpful contribution from academics and energy modelers that help us also a lot on on making our assumption more robust. So I won't speak for too long because I would leave the floor to you. Actually, we wanted to actually get your feedback on, for those who has been involved by near or far on the PAC scenario, on how was also your let's say user experience of the PAC scenario, because of course on our side it's also very important to know a bit how you perceive this exercise, what you believe was useful, what was the most useful for your organization, and what also could be improved or could be further researched. We have already a bit of ideas from the chat box, but this is also very important to us. So without further ado, you will hopefully see in front of your screen appearing now our first survey. So you will be asked to answer a couple of very quick and very simple questions on your screen. So about how the PAC scenario was for you, your organization, and how you used these results. So now I hope that you will see on your screen the PAC scenario poll, which is your feedback on the process. So there are basically 3 questions. It's very simple. It's also for us to know a bit how to position ourselves. And I see that the first starting, you can of course start filling the boxes and filling it as I'm speaking, because we will eventually close it and move forward, and you will have the results eventually. So I see that you are quite active, which is very good. So the first question is more about the use, of course, of the PAC scenario, and then we try to analyze what chapter, what elements of the PAC scenario were the most useful to you as your organization, and also perceive how these further could be improved and used. So I see that no, almost half of you has voted. So I'm currently expecting the rest to continue voting and to complete this figure and this polls. So our aim with this poll, I mean, just to explain also to you, is on the top of reporting, it's also to do a bit of seeing how we can calibrate and discuss for the future, because we will talk about what has been done on the top of the PAC scenario results and what would be done in the future. So voila, I mean, I see that the poll is now almost 80% moving and 80% completed for all the participants. So thanks indeed. A quick reminder for those who haven't replied yet to reply. And without further ado, I will leave the floor to Jörg, who will then introduce some questions about the PAC scenario, some of these questions that you have asked actually, and how we started also together with academics and modelers to try to endeavor to answer them and what we could do in the future. So Jörg, the floor is yours, and the poll will close in a bit.
Good, thanks a lot also for giving us your opinion in this poll. As I mentioned already in the first part, for those who joined for the quick introduction of the PAC scenario findings, there are, of course, gaps in this analysis that we did. This PAC scenario does not say how much it really costs to transform our energy landscape into an energy system that is compatible with 65% emission reduction by 2030 and net zero by 2040. We can say that, of course, we can reach with these changes our climate targets, but we did not dig deeper into specific emission reduction pathways, for example, on non-CO2 related emissions, on non-energy related emissions and carbon removals. The entire sector of land use change and forestry was not yet really touched upon during our workshops with members and stakeholders. And one question that we often received from our national member organizations: could we please have country-specific results from this PAC scenario? For the time being, we do not yet have any national PAC scenarios, but it could be an option to develop these. For the next hour, we will try to provide you with some potential answers to these questions, thanks to the guests that we have, guest speakers from science, who already have worked with the PAC scenario, who accompanied the process during the last months. We exchanged data. Some of those have already worked with our data. We published an open license data set on the website so that everyone can use and double check our numbers, our assumptions. And we will start with a first introduction, with a first presentation of roughly 10 to 12 minutes. You will then immediately have another 8 to 10 minutes for questions to discuss the findings of this presentation. And step by step, I hope that you will get a better understanding of what could be future avenues of our work with the PAC scenario, how you could use it, and where it is worthwhile deepening this work, also in view of the feedback that we just received. And after this, these three presentations, we will try to wrap up and check again with you what you expect and how we as CAN Europe and EEB should continue this work with the PAC scenario. So I'm very happy to welcome our first guest speaker, Christian von Hirschhausen. He's a professor at the Workgroup for Economic and Infrastructure Policy at Berlin University of Technology. He and his team have extensively intensively discussed with us the key assumptions, and he and his team published a very interesting study on how to implement the European Green Deal, what that means in terms of costs and benefits, also in view of higher targets. He shows that it's really worth increasing the level of ambition in Europe. So I would invite now Christian to present his findings, his assessment of also the PAC scenario, and give an overview of his work in this regard. I will stop sharing so that Christian should be able to show his screen.
Okay, thank you very much, Jörg, Jonathan, and everybody for this excellent overview. Can you hear and see me?
Yes, we see you and we see the presentation.
Okay.
Just switch to exactly to the full screen. Thanks a lot.
Okay. Well, once again, thank you very much for the introduction. And first of all, I think let me pass a word of congratulation to this exercise, which is, as you mentioned in the introduction, unique and gives a very good occasion now to, as we say in our group, to now we can start to work. And that's why I split up this presentation into two parts. I want to add a couple of issues that we kind of sidelined to the PAC scenario from a team consisting of TU Berlin and the German Institute of Economic Research, DRW. But then I also want to give an outlook to future potential activities by the European instances, EEB and CAN and others, but also at the national level, because we need to translate this into national policies. So this has two parts. One is the presentation of the study that was mentioned, that we got into the process relatively late, but I think we caught up, and so we developed a similar scenario, a little bit technically different in terms of the definition of the sectors, but anyway, with the same objectives, that is Paris climate targets. It's called Make the European Green Real Deal Real, and combining climate neutrality and economic recovery. And it has, as you will see, the same objectives in terms of carbon reductions and in terms of decarbonization. Essentially, it consisted of coupling a top-down model, which is called Genesis Mod, where we had the occasion to use a scenario from another EU project, the Open Entrance project, with a bottom-up model in electricity and heat model, AnyMod, and also to add, I will put the photos here, to add economic analysis. It's not macroeconomics in the proper sense, but we have economic implications of decarbonization investments. Essentially, what will happen under such a scenario, that until 2040, carbon fuels and nuclear power is phased out step by step, coal, oil, natural gas, and nuclear, and there's a mix of renewables. I think we have a little bit more biomass than in the PAC scenario. We have lots of wind onshore and offshore. We have hydro, and increasing role of solar, of course. Importantly, we keep the budget. This is a very important issue. I think we should talk about gross decarbonization and not net decarbonization, because we don't have technologies to introduce in 2060 or 2080 that could make up for an overuse of the budget. So we have a budget approach, and the reduction of CO2 emissions, CO2 only in this case, are calibrated to the Paris Agreement to the extent that by 2040, gross zero carbon emission is attained in different sectors that correspond more or less to the PAC scenario. This is important because, as you know, currently there's a discussion ongoing in Parliament, Council, etc., on the targets for 2030. We say that the target for 2030 should be 65%. This is the green chart here that you see, and with respect to the current 40%, we see it's about half of the emissions by 2050, and it needs to be much earlier than in the 40% scenario. It also needs to be much earlier with respect to the current proposal of the 55% put forward by the Commission, because the budget is decreasing. We have increasing values of methane, which is more potent than previously acknowledged. We have a shrinking budget. So actually, we need climate neutrality in 2035, which is interesting, but which gets us into the discussion later on, if we want to be consistent with the budget. In terms of macro indicators, we have calculated that we do huge economies of fossil fuel imports. About 2,000 billion euros are economized, which justifies significant investments into renewable storage technology, some infrastructure, at the height of about 3.4 trillion euros. So we have a positive cost-benefit analysis if we value the environmental externalities at their true costs, which is an important finding. Let me just show two results with respect to sectoral decarbonization. We are quite advanced with the coal phase-out. In most of the regions, actually over the last half year, since this discussion has started at the Brussels level, countries have opted into more ambitious coal phase out, for example, Poland, for example, Greece. And we have also the necessity to have a natural gas phase out. This is somewhat new to some of the stakeholders, but of course, does not make sense to limit the phase out to coal. Natural gas has to disappear because it is directly burning and producing CO2, but also the upstream leakage issues lead to a very tough problems in terms of CH4, which, as I said, is about 100 times more potent than CO2 in the short term and currently underestimated. What is interesting in our exercise that we have developed in the bottom-up level model, a methodology to have hourly results for every country. And actually Leo Goeke, who may be in this call, but who may be working, is able to produce this. Let me just show you the results for two countries, France and Poland. And within, I exaggerate a little bit, within 5 minutes, we can produce any other country, because that gives you arguments at the national level to say, okay, France, we can do 100% renewables by 2040. And here's the supply side, offshore, solar, of course, import and exports play an important role, but we can also do it for Poland. This is a week in 2040. This is the 3rd January week. And we are happy to provide these analyses with due time constraints for producing them if you're interested. And you can match them with the demand side. You see that the electrification actually leads to a higher peak demand. For France, for example, it goes from about 110 gigawatts now to 200 gigawatts. But it can be done. And I think that is a good guide way for national discussions. Decarbonization is possible and the lights don't go out and the heat stays on as well. Okay, I jump over an important session, which is the just transition for time reasons. It is available. And let me give you a very brief outlook to what I think you and we and others should do based on the PAC exercise. I think we need to provide a critical assessment of the assessment, the impact assessment, I mean. And then second, our interest is in linking the PAC scenarios with the European infrastructure programs. So let me just provide you a very brief insight into that. A couple of weeks ago, the impact assessment was published, as most of you know, and it has a target which comes too late, comes in 2050, and which ignores the budget approach. If you do I did this, if you do the math on this triangle, you come up with a much higher emission budget than is available according to the Paris scenario. And that's independent actually of whether you follow a more stringent approach or the current approach. So this triangle here, let's say 3.5 multiplied by 30, gives you about double the budget that is available, which is, I think, not corresponding to the Paris Agreement. And it also has, as some of you know, the LULUCF emissions that are somewhat unstable. It also relies on carbon dioxide removal, CDR, and on something that is implausible in our opinion, that is what's called the subtraction of emissions, sometimes called negative emissions, that is not foreseeable for the time being, and which puts too much emissions in the current period. Another issue that I think I'm the only person to have mentioned over the last year or so is nuclear power. I know that this is a sensitive topic at the European level. I'm a little bit surprised that the environmental organizations don't put that forward more strongly, but there may be reasons. You see in this yellow bar here, increases, the yellow bar, which is nuclear, increases in share from about 13% to 15 to 16% by 2050, which implies about 3 gigawatts of construction every year. You must know that over the last 20 years, we have not built 3 gigawatts in the EU. And so this implies a kind of renewal of nuclear power, which is economically not sensible, and it's dangerous for our health. Okay, let's come to the outlook. If we talk about decarbonization, we need to talk about infrastructure. That's because our chair is called infrastructure policy, but I think you agree that the TYNDPs are important. And this is in terms of electricity, natural gas, and hydrogen. And I think we'll have the next presentation by Tom Brown that provides more detail. So let me just say that the current TYNDPs, both for natural gas and for electricity, do not correspond yet to the constraints that have been identified. In terms of the electricity TYNDPs, there's still lots of coal, in black here, natural gas, and nuclear in there. In particular, look at natural gas. Natural gas is almost constant in these scenarios at about 150 gigawatts. Coal is still very active in 2040. And in the natural gas TYNDPs, the gas demand remains very high in different scenarios. I don't go into detail here. And there's a kind of attempt to substitute natural gas by hydrogen. Now, technically, this may be feasible to a certain extent. Environmentally, this is not sustainable because these high levels of gas are incompatible with the climate policy agenda. And we are in the process of doing more detailed analysis of linking the national with the TYNDP plans that are in some cases inconsistent. But I want to leave it at this point. For the further outlook, further work, national analysis, critical assessment of the assessment, and work towards sustainable infrastructure. And we are available, and we're very much interested in continuing this debate with you, and look forward. Thank you very much.
Thank you, Christian, for respecting the time limits and for this very instructive overview with regards to how the PAC scenario also could be improved. We have the opportunity to answer a few questions if you use the Q&A box. I know some prefer the chat box. We are flexible, and whatever you want to raise now or ask to Christian, feel free. We have still some time left for this exchange. I see a question from Holger to Christian. Have you also included heat storage in the model? Yes.
Yes. Yes. We have included heat storage. I can share to show you just an overview of the types of storage that are being used in the case of the hourly. No, it's not well stable here. So we have actually the AnyMod model provides 4 hourly heat demand and storage. That's a big advantage with respect to the previous analysis that we did. So the electricity, what I mentioned, the electricity system is modeled at an hourly level, and the heat at a 4 hourly level. So actually what you have in the peaks is mainly transfer of heat towards, and also via hydrogen, towards the winter period, which you see in the peaks. So that includes, of course, hydrogen, but it also includes power to heat applications. So that's why the peak via electricity is so high. I think this is a critical aspect that in the next exercise we need to be more specific on heat demand portfolios and in the different countries, which we have not done in the current exercise. I see a question here on space in terms of space availability, for example, in Poland by Wojciech. As you see from this graph, a large part of the exercise for Poland consists of onshore wind. We also have a little bit of offshore wind, but Poland has good sites, not perfect sites, but good sites for onshore winds. And it might be useful to, when we translate this into real projects, to check the availability of land for onshore wind, for example. We have done this in the case of offshore, but we have not looked at each country on the country-specific sites for renewables. We have done this for Germany. In Germany, it turns out that there's sufficient space available for onshore wind, and also in the case of solar, we need housing. We need not only large-scale solar, but we need also rooftop solar to comply with the rising requirements for solar and for renewables. Now, other questions in the F&A? I didn't understand.
The increase of nuclear from Carlotta, the 3 gigawatt nuclear, where does this?
Well, this is a question that since the assessment has come out, I've been asking to people. If anybody in the audience can help me, I'd be very happy. Because technically it's not possible. You can't have an optimization problem that includes nuclear, because nuclear is too expensive. So my suspicion is that the exercise includes estimates from national member states. We want X and we want Y, and then they kind of force it into the model exogenously. Otherwise, it's not possible. I've checked this in previous reference scenarios, and we've done our own modeling work. Now, the 3 gigawatt is an interpretation of the 15% that we have in final electricity demand for 2050. And let me probably just show this as a last slide, because this is one of my favorite slides. And the decay of normal decay of nuclear power according to the lifeline of 40 years, which is the normal period for a nuclear power plant. Think of Tihange, think of Duel, think of others that go beyond. You should not do that. It's just dangerous. Don't forget, nuclear power is dangerous. It is not controllable, right? We can't avoid accidents, and we should not risk it. So this is the normal lifeline period where you assume 40 years. We still have, if it ever goes online, Olkiluoto and Flamanville back here. We might assume, since it's too expensive to maintain the entire infrastructure, that they will be shut down prematurely. I think in the PAC scenarios, you have made the same assumption. But this of course, is a very stark contrast to these 15% here in 2050. And whoever is interested in studying this with us, I welcome you to this analysis, which I think is kind of undervalued in the overall energy transformation. Thank you very much.
Thank you, Christian, for your support to the PAC scenario building process and for this very illustrative, instructive insights. And I think we fully agree that when it comes to the scenario building, it is, of course, more than just a scientific exercise. It influences policymakers, it influences investors, and we need to make sure, when you talk about infrastructure, we need to make sure that this does not end up as a kind of self-fulfilling prophecy, so that we end up with a kind of lock-in into fossil gas infrastructure. For example, if you build these pipelines, someone will use them, and we stick still to fossil gas, which is, of course, not compatible with the Paris Agreement at all. I will now introduce our next second guest speaker. Welcome to Elisabeth Zayen. She's a PhD student in energy system modeling from Karlsruhe Institute of Technology, KIT. She fed together with her colleagues, with the team, Professor Marta Victoria from Aarhus University, and Dr. Tom Brown he's the head of group energy system modeling at KIT. They fed the PAC scenario data into their own open source model, which has a very complicated acronym, but provided us with very, very helpful and fascinating additional information with regards to also sector coupling, interaction, and infrastructure, also with regards to costs. So I would like to invite Elisabeth to share your screen and launch your presentation. Thanks.
Hi, everybody. My name is Elisabeth. I'm a PhD student at Tom's Group at KIT. And together with Marta, who's professor at Aarhus University, we were running the PAC scenarios with our sector coupling model PEPSA EUR-SEC. So PEPSA EUR-SEC is an open model, as Jörg already said in his introduction. What means that all the code and the data is public available. What have we done? So we took the PAC scenario assumptions, which Jonathan and Jörg already presented this morning, and we disaggregated them. On the one hand, on a temporal level, as you can see on the upper right graphic, for example, for the hot water and space heat demand, and also on a spatial country level, as you can see on the lower bottom graph on the right-hand side. We've been modeling the PAC scenarios on an hourly resolution, and our model does include all the EU 28 except for Cyprus and Malta, but also 7 non-EU countries, such as, for example, Switzerland and Norway, and those are important to include to really model the electric grid. And we distributed the demand, which is assumed in the PAC scenarios, temporal and spatial on a country level. And we took account for like current energy infrastructure, like, for example, the current transmission grid, but also we took account for land restrictions. So, for example, wind farms cannot be built in regions where we do have nature protection zones. So what have we taken from the PAC scenarios? We took the total demand, which are giving for every year, for example, for the electricity, heat, and transport. But we also took the phase outs of the conventional plants, like coal, lignite, or nuclear power plants. The efficiency improvements, and also the annual CO2 limits. And what did we optimize in our model? We mainly optimized the supply side. So we have a look at the generation, storage, and transmission, and the hourly dispatch.
Elisabeth, could you please speak up a bit? Some participants have problems in understanding because the sound is not that strong, apparently.
Okay,
to the microphone. Thanks. Sorry for interrupting.
Hopefully it's better now. So what are the advantages of modeling with PEPSA EUR-SEC? So first of all, we do have a high temporal and spatial resolution. And we optimize simultaneously the transmission, the storage, the generation, and the dispatch. And we can capture also the benefits of sector coupling. But there are a few limitations. First of all, we have to do simplifications to distribute the demand. For example, the agricultural demand is distributed by population. And our results strongly depend on the boundary conditions. So, for example, if we do allow higher transmission capacities, we would see higher wind capacities in Denmark, compared to a case if we don't allow any further transmission capacities. And as a third point, there are many near-optimal solutions. What does this mean? So normally we minimize the total system cost in our optimization, but there are many solutions if we are allowing to pay maybe 1 or 2% more compared to the optimal solution, which completely looks different. So this is important to keep in mind, which might have a higher public acceptance than the cost minimal solution. In the following, I'm going to show you a few results, but those results are all preliminary. So we still keep on iterating, and as always, feedback is very welcome. What can we learn from modeling with PEPSA EUR-SEC? So on the one hand, we get like hourly generation, storage, and demand information, and That's what you can see on the left-hand side in the graphic. So it shows the total electricity generation in Europe for 2 example weeks. On the left-hand side for winter week in February, and on the right-hand side for an example week in July. And positive are values. Positive is shown the supply, like for example, the generation from wind farms or from conventional power plants. And negative is the demand, which is on the one hand the electricity demand, but also demand for the electrified heating sector or for electrolyzers. And as a general picture, we can see that from the top, from 2020 down to 2050, the electricity demand and generation is increasing. And we can also see on the left-hand side that for the winter, the wind feed-in is higher, while in the summer times, the feed-in of solar is higher. We do get those typical day peaks from the solar PV plants. And we can also see that, for example, when we have high excess electricity, that the electrolyzers are used. On the right-hand side, we can also see the spatial distribution of the total system cost. This is with the conservative assumption that we don't have any further transmission capacity extension. And we can see what one would also intuitively expect, that there are more wind farms in Northern Europe and more solar PV, which is displayed in yellow in southern countries. What other information can we get? So we can also get information about the system costs, but those system costs are only for the energy supply, which we show here. This is in the graphic on the left side. They are showing the total system costs per year from 2020 to 2050. And it looks like they are decreasing, but this is because we don't consider here costs for efficiency improvements. For example, if the heat demand is decreasing in the building sector, there would have to be investments into building retrofitting. We don't include costs for electric vehicles or also for switching industry processes. But one general picture one can get that in 2050, like the largest fraction of the total system cost is relying on and offshore wind, which is displayed in blue, and on solar, as well as hydrogen storage, which is pink here. And we can also get information about the installed capacities, which is on the right-hand side for the years 2020 to 2050. In the upper plot, we can see the capacities of solar on and offshore wind with, for example, solar capacities in 2050 of roughly 1.7 terawatts. And we can see that the storage capacities are rising as well for batteries and water tanks, which we assumed as thermal energy storage, while the storage of gas is decreasing strongly from 2040 onwards. And in the last row, we can see information about the hydrogen infrastructure, which is mainly used from 2040 onwards, with a very large hydrogen storage and about 500 gigawatt hydrogen electrolyzers and 100 gigawatt fuel cell capacity in 2050. So we can get with our model information about the storage capacity, but also about the energy in the storage during the time, and that's shown in the left-hand side. So we can separate the storage into long-term storage, which you can see in the left column, which shows like the energy in the storage for a whole year, and into storage, which is used only short-term, which is in the right column, and we do see the energy in the storage for 1 month. And as long-term storage is used, for example, hydrogen gas and thermal energy storage in form of central water tanks and district heating systems. And we can see, for example, that the hydrogen storage, which is in the upper left plot, that it's mainly used from 2040 onwards, and we can also see the strong seasonal pattern. On the right-hand side, this is the 2 example days for Italy in the summer months in July in 2050. And we can have a look also with our model on the interplay between generation and storage. So in the first two rows, we do see the solar feed-in, first on solar utility, but also of solar rooftops with the typical day pattern. So at noon, we do have the highest solar feed-in. Below in the third row, we see the energy in the battery, which starts charging with the higher solar feed-in and discharging in the afternoon. And we also get information, for example, from vehicle to grid, which is in the last row, which starts charging in the evening and discharging during the night when we don't have any solar feed-in. We can also give information about the hydrogen network. So, for example, on the left side, you see a map of Europe with the electrolyzer capacities displayed in pink, which are mainly installed in countries with a high wind feed-in, but also with the capability of storing the hydrogen in salt caverns. And you do see where the hydrogen pipelines would be built. In this model, we didn't assume any retrofitting of existing gas pipelines and just newly built hydrogen pipelines. And on the upper right-hand side, you can see the duration curves of the electrolyzers for all of Europe in red, and also for 3 example countries. And we do get full out hours of electrolyzers for all of Europe of about 3,500 hours per year. And as an example, on the lower right, there's the onshore wind feed-in of Great Britain in 2050 for 1 example week. And we can see that the electrolyzers follow the feed-in of the onshore wind. So when we have a high excess electricity, the electrolyzers are used more. And also on the usage of biomethane and synthetic methane, we can get an information, as you can see down here in the plot. So the demand is displayed positive, and the supply, which can be from fossil gas methanation or upgraded biogas, is displayed as negative values. And first of all, one can see that it's decreasing strongly in 2040, and that all the gas which is used from 2040 onwards in our model is just supplied by upgraded biogas, and no methanation process is needed. So what is the conclusion? First of all, the PAC scenarios are all feasible for all years with hourly resolution. So the lights won't go out and the heat supply is assured. And what can we do next with the PAC scenarios? We can run the scenarios with a higher spatial resolution, as you can see in the graphic on the right, which is with roughly 360 nodes instead of just 1 node per country. And we can explore further the balance between higher transmission capacities or higher storage capacities, but we could also consider social acceptance problems, like, for example, problems with installing more onshore wind farms. And this is my last slide, a sneak into what we are already doing in our research. So this is an example for on the left side for a higher spatial resolution with allowed transmission reinforcement. So in the result before, they were all with the conservative assumption that we don't have any transmission extension. Or on the right-hand side, also having a look on the hydrogen infrastructure with a higher spatial resolution.
Thank you very much, Elisabeth. This was really a very great and insightful journey, a travel through the many options and functions that your really amazing model provided to us. We could spend hours, and I'm still quite fascinated always when it comes to the results and the new insights that we get after having worked 1.5 years on the figures. Now you really fine tune and explain the sensitivities, the interrelation and so on. We have maybe time for one very short question. Time is running a bit away. There was one question from Raffaele regarding which renewable electricity electrolyzers would use. It looks like they are powered mainly through wind electricity. Is there a reason not to use, to a larger extent, PV?
Then the
So I would say I'm also involved in the modeling that the wind tends to get higher full load hours, so it tends to be preferred by the model for the electrolyzer pairing with it. So economically, it suits the wind better. But as you saw in that last slide, there was also some electrolyzers being built in the south, in Italy and Spain, which were also being used to some extent for the electrolyzer capacity. Maybe Marta can quickly comment on the question about the heating and the cooling, because you've also looked at this and the climate change impacts. There's a question in the Q&A, Marta, about cooling and the heating demand.
Yeah, sure. Yeah, I just read it. So sure, what we see in the model is that first of all, that cooling demand, which is expected to increase in southern countries, is very well synchronized with PV generation. So with the cooling demand that is coming in those countries in the south could be easily supplied by solar PV because it generates at the same time. Regarding the heating demand, which is more demanding in northern countries in Europe, well, that's a huge challenge because the seasonality of heating is significant, and is much more significant than seasonal variation in electricity demand. So for that, what we see in the model is that mainly district heating system together with thermal energy storage, for instance, these huge water pits associated with district heating system that are used today in Denmark, for instance. Well, those are a very cheap way of storing energy during summer months, and then discharging during winter months where we have peaks in heating demand. So we see different balancing strategies to supply both cooling and heating.
Thank you, Marta. Would you also like to briefly respond to the question from Christian Breyer? Christian is one of the authors of this LUT model from the Energy Watch Group, which we used in our PAC scenario also when it comes to solar and wind potentials. He was asking whether a higher PV share would lead to lower costs. He wrote, in our studies, we learned that low-cost PV batteries, vehicle-to-grid electrolyzers, all strongly push larger PV shares.
So maybe I can give a general answer to this. So what we, and then Tom, you can complement that. What we see, what Lisa saw was the cost optimal result. So those configuration that minimizes the system cost. But as she was pointed out, there is possibility to explore near optimal solutions, or solutions which are going to be just slightly more expensive, maybe 1% more expensive, but they allow a different configuration. And one of these different configuration could be favoring solar PV. And we may prefer that as a society. We may prefer having a configuration with less transmission interconnections and more locally produced electricity or more rooftop solar PV. And I really think that's really interesting to investigate if we can achieve not only a transition path that it's compatible with the Paris Climate Agreement, but also that it's that entails benefits from a social and other environmental perspective.
I agree with everything you said, Martin. I'd only add that we do have quite a lot of PV. I mean, we have between 1.5 and 2 terawatts of PV in Europe, but wind is still playing a strong role, and that's primarily not just cost-driven, but by the seasonality of the profiles. That because of the heating demand, there's a lot more demand in the winter, and so that tends to favor the wind, which is stronger in the winter. So there's that component as well as the cost component.
Yeah, thank you, Tom and Marta. I mean, also to bear in mind, your model started with the assumption that no further expansion of the European electricity transmission grids would happen. In case you were more optimistic with regards to interconnector capacities, the picture could look a bit different also with regards to hydrogen and so on, but that's another story. We could organize another webinar maybe on this topic. I see there are a few more questions also with regards to country-specific assumptions on France and Portugal. I would like to answer maybe bilaterally at a later point in time. And with regards to David's question on the seasonality, heating and cooling of buildings, I think this is covered. If you can say one sentence or just maybe have another email exchange afterwards, because I still would also like to give sufficient time for the third guest speaker.
We have looked at putting climate change into the model to examine those seasonal changes, especially on the electricity grid. I'm not sure we've done it on the heating sector. Have you looked at that in your group on the heating sector, the cooling, the seasonality of the cooling and the heating demand, Marta?
Yes, we have done some analysis in which we assume the impact of climate change on the heating demand. And this, of course, what we see is that the main effect is that heating demand peaks in the winter are going to reduce, are going to decrease. And that makes easy the operation of the system in northern countries. That's the first most significant impact that we see. We also see some increase in cooling demand in southern countries, but as I was saying, it's less difficult to be solved by the system, because at the same time we have all the PV coming and generating simultaneously to the cooling demand.
Okay, let me thank you once again. We definitely will continue this exchange, and we are very happy to have you here on board. There is a third guest speaker, and as we mentioned in the introductory session, the PAC scenario did not yet really touch upon details with regards to emission pathways, emission reduction pathways, also carbon removals. We have an expert to cover this area, and we already are actually in a formalized new project with partners on the 1.5 degrees pathway project, which is a consortium of Climate Analytics, our Swedish member ERCLIM, and Can Europe, where we explore how to translate the PAC scenario into an EU-wide emission reduction pathway compatible with the 1.5 degree target. And also we are planning to derive country-specific figures and sector-specific emission reduction pathways thanks to the work of Climate Analytics. I welcome Ryan Wilson. He is a climate and energy policy analyst with Climate Analytics, a non-profit climate science and policy institute based in New York, in Berlin, Lomé, and in Perth. He will give you an introduction into this new project that we just launched, and also dig a bit deeper. Thank you also to Ryan for the huge work that you already did, in particular also in spotting some inconsistencies in some details of the numbers of the PAC scenario. So we are also looking forward to continue this work, and the floor is yours. You just can share your screen, I think.
Okay. Thanks, Jörg. Thanks for that introduction. Can everyone see my screen? Okay, just yeah. Okay, great. So yeah, Yogi did a good job introducing the project, so I don't need to go too much into that, but I will just give a quick overview of the presentation. So I'll do another quick sort of overview of the project. I'll introduce the current existing global Paris Agreement compatible emissions pathways that are out there, how we downscale those to the national and the EU level, touch on some potential improvements to the PAC scenario, and hopefully there's some time for discussion, questions at the end. So just a quick introduction. The goal of the project, as Jörg said, is to provide Paris Agreement compatible economy-wide and sectoral emissions pathways for the EU and 9 member states that you see here on the right. It's roughly a 1.5-year project going until the end of next year, and it's funded by the Swedish Postcode Foundation. So currently there exists a number of global and regional Paris Agreement compatible emissions pathways that have been published. However, this is not the case for many countries. They're not available, and also at the sectoral level, they're lacking. And we know that currently the 2030 aggregate of 2030 emission targets and policies are insufficient to achieve the 1.5 degrees long-term temperature goal of the Paris Agreement. So the aim is to provide key resources for stakeholders and policymakers for use in developing more stringent national emissions targets that are required, but also stronger policies in key emitting sectors. The outputs of the project are a final report that will include these EU and national economy-wide sectoral emissions pathways, and a discussion of the current EU long-term strategy and the net zero 2050 target, some country fact sheets on the countries that we're covering in the project, and some communications and outreach as well. So just to introduce these pathways that exist, you're all aware, obviously, that the long-term temperature goal of the Paris Agreement, which is to hold warming well below 2 degrees above pre-industrial levels, and pursuing efforts to limit the increase to 1.5 degrees, and then achieve zero greenhouse gas emissions in the second half of the century. Now, the special report on 1.5 degrees that was produced by the IPCC included a number of mitigation pathways, with the majority of these being derived with integrated assessment models covering all regions and sectors. And the starting point to these models to the end of the century, these models choose the mitigation options in any region, sector, and time, so that overall and globally and over the century, the climate target is achieved in a cost-effective manner as possible. These IAMs are designed to consider gradual changes to existing systems, and so therefore they're not very good at capturing rapid technological advances and systemic tipping points. A lot of these IAMs also depend on high levels of late century use of carbon dioxide removal and bioenergy with carbon capture and storage due to assumptions on technology availability and economic discounting. So climate analytics actually pre-filters these scenarios in the special report on 1.5 from the IPCC according to a more stringent and what we would consider a more realistic criteria. So low temperature overshoot in the second half of the century, limited use of carbon capture and storage, and carbon dioxide removal. So here I just wanted to show some of those pre-filtered scenarios that we filter out of the existing IAMs from the IPCC special report on 1.5. Here you can see 6 represented with global primary energy demand. I just wanted to show these as a way to demonstrate the variation across these scenarios in some of the sort of key technologies assumed. So you can see in the light green, even still, some of these scenarios include substantial use of bioenergy with carbon capture and storage in the second half of the century. Some have assumptions of higher energy demand, total energy demand, where others have lower, and some include substantial nuclear, others assume very little. But they are all considered to be compatible with this 1.5 degree temperature goal. So how do we get to the national and EU pathways from these models? Just a very sort of high level overview. Each of these models, they have not just global analyses, but also regional. And so, for example, I've given you the example of the message model here. They have the model region, Western Europe. So if we want to, for example, take or achieve the national pathways for example, Spain or Germany, like shown on the right-hand side, what we need to do is match the historical emissions for each country and sector that we're wanting to look at. We then downscale the future emissions for each of these countries and sectors if we're doing a sectoral analysis. And in terms of the sectoral analysis, what we do, we assess the results, engage with the stakeholders that are relevant for the project that we're working on. So in this instance, CAN Europe members, in order to capture the necessary dynamics and policy context of the national level and the sectoral level, and then we can iterate the results at that stage to ensure that we're capturing those necessary dynamics, so that the results make sense and reflect the national policy context. Now, in order to get the EU level pathway, these models they have multiple different regions. So the EU, the countries span not just one region but multiple. So in order to get the necessary aggregation, again using the message model as an example here, the EU countries span both the Western Europe and Eastern Europe region. What we need to do is downscale all of the countries in both of those regions, and sectoral emissions pathways, and then aggregate them together to construct the region that we need, which is in this instance the EU 28. So what you see here is a representation of these pre-filtered scenarios. This is CO2 emissions from total primary energy supply, and what we wanted to do is compare these with the PAC scenario. You see the PAC scenario there in the black. It's the black line. And you'll notice two things here. One, that the PAC scenario for these CO2 emissions from primary energy supply are more ambitious than these pre-filtered scenarios, but also that in the base year in 2015, the level of emissions is substantially lower than those that we find in those pre-filtered scenarios. And we're able to account for that by using higher emission factors. But it does imply that there is some demand data missing, and I'll come back to that later in the presentation. But what we really want to compare is this economy-wide greenhouse gas emissions pathway. So what you see here are the three most ambitious IAM scenarios, the green, blue, and red, and then the PAC scenario there in purple. So in order to drive this, we take those CO2 emissions from primary energy supply, and then we need the non-CO2 and non-energy CO2 emissions to supplement those. We take the trajectory of those emissions from the most ambitious IAM scenario here, which is in this case the image SSP1 1.9 scenario. We transpose that onto the PAC scenario, and this is what you get as a result, this purple line. And so again, you can note two things here. It still remains the most ambitious scenario there until 2040, but you'll also notice that the total emissions do not go to zero in 2040 as the PAC implies. And the reason for this is in all these IAM scenarios, the non-CO2, non-energy CO2 emissions do not go to zero a lot of the time. The reason you see in the green and the blue scenario there that they go to zero and then go negative, they have like quite high levels of bioenergy with carbon capture and storage. You see there in the red, in the message low energy demand scenario, there is no bioenergy with carbon capture and storage, and so therefore those emissions stay above zero. But this does not imply that emissions overall do not go to zero. What is implied by this gap, because these emissions, as you can see, are excluding LULUCF, so land use change and forestry emissions, it implies that the gap there is achieved with emission reductions from this sector. And again, I'll come back to this a bit later in terms of how potentially we can get some improvements in the PAC scenario, but just to note for now. So what could we get from these emissions trajectories? Well, two main things. If you note the red line, it represents an overall carbon budget. So having an overall carbon budget that's 1.5 degrees compatible, it's a useful tool for policymakers, but also having the trajectory over time It tells you in one particular year, or what would be a 1.5 degree compatible level of emissions, which then can enable policymakers to derive emissions targets in those years, so 2030 or 2050, Paris Agreement compatible national emissions targets, and also sectoral. So sectoral analysis is also very important. As you can see here, there are a number of key shifts that need to happen at the sectoral level, and again, providing a demonstration of what a sectoral emissions pathway that's compatible with 1.5 degrees. It's a strong incentive to sort of push towards the implementation of policies that achieve these necessary interventions achieve the sectoral transformations that we require. So what we aim to provide is this more granular depiction of a 1.5 degree compatible emissions pathway, and we intend to engage with CAN Europe members, as I mentioned before, to ensure that the pathways that we provide really do reflect the sort of necessary and the relevant policy interventions and planned policy interventions, so that they are as useful and relevant as possible in the national context. So just quickly, a couple of potential improvements to the PAC scenario that we noted. So I'll take you back to the CO2 emissions from total primary energy supply here, and I did note that we accounted for that differential in CO2 emissions in the base year from primary energy by adjusting the emission factors. What we used in the end, what we had to use in order to match those emissions with what we see in historical emissions were the emission factors for all fuels at the very top of the range of emission factors in the IPCC guidelines. However, this is not a realistic assumption. It basically implies that all of the fuels, different types of fuels that are burnt in the EU, are the most dirty possible versions of those fuels, which is of course not true. So ideally, we would like to enable the use of more realistic emission factors, but that implies that there is some demand data that is missing from the scenario, and an initial analysis of that suggests that that could be coming from coal use and oil use from the EU. But I know Jörg and Jonathan are already looking at this. But the other key thing to note, again, going back to this demonstration of the overall greenhouse gas emission pathways on the right here, the PAC being in the purple, the fact that it doesn't go to zero, just contrasting this with the emissions profile in the PAC scenario, where you have net emissions going to zero in 2040. It is implying two things that need to be considered. So given that the projections for emissions in the land use change and forestry sector of the EU are substantially negative and remain negative over coming decades, given this projection of the PAC scenario emissions is excluding LULUCF, it actually implies that in 2040 you'll have net negative emissions actually. And that is the sort of one of the key differences here, where you see in the purple, emissions are still positive. Well, that's because it also doesn't include these emission reductions from LULUCF, but it also implies this emissions trajectory from the PAC scenario that these non-CO2 and non-energy CO2 emissions go to zero by 2040. And as I mentioned, in the IAM projections and scenarios, this is not the case. They are considered to be much harder to mitigate those last emissions, non-CO2 emissions. And so it suggests that there's some further consideration needed on how the PAC scenario addresses these LULUCF emissions and non-CO2 emissions over time. So I think that's probably my time, but if there are any questions, I'm happy to answer them.
Thank you very much, Ryan, for this overview into a project that already started internally with CAN Europe and members. Just to make clear for members who are interested, we are organizing another dedicated workshop with climate analytics with Ryan and his colleagues in November during our annual General Assembly to prepare more of the details of this exchange, in particular with regards to the engagement of the national member organizations from those countries for which we plan to derive those country-specific emission reduction pathways. If there are no further additions or questions, I don't see anything in the chat box or in the question and answers box. I immediately would hand over to Jonathan and ask him to provide the summary, respectively, the feedback from you that we asked in the beginning.
Thanks indeed, Jörg, and thanks to all the presenters for the very interesting presentation. So without further ado, I would like to first thank you also for your interest and questions, because I see that there have been a lot of questions on the chat box and on the Q&A as well. A lot of questions, a lot of interest shown. Also, people expressed some concerns. So I have also good news that we are aware of some elements. We are aware of some potential needs way forward for the PAC scenario, which is currently an energy only, mostly energy scenario. So we are aware of this, and we would like to move forward potentially with you and who's who are interested. Without further ado, I'm allowing just to briefly share the results of the previous poll. So you should now see on your screen the results. So I will start with the last question, which is for me the most interesting, which was very helpful for us. Most of you, 80%, find the scenario relevant or very relevant, which is good news and which shows also the interest. And no, I must say that the question one reply surprised me a bit, because of course everyone finds it relevant, but the results are not always used. So it's now our job as well to think together and to think as a PAC project team how to make our results and potential further work even more useful. And for this, we have prepared another poll, which is in the same on the same formats than the previous one. Also to know on your side what would be of your interest to move forward with potential next steps or potential further research on the PAC scenario. So you should now see displayed on your screen the next poll, which is quite simple actually, but I will still present it to you. It's also for us to know a bit and calibrate. You can answer it. So I don't see yet people, so you are able to answer it. The first question is extremely simple. It's what would be the potential further working areas? You have seen presentations, you have seen studies on different working areas. Please, for the first one, it's multiple choice, only choose two, so that it helps us discriminate and help us choose also what would be interesting. And also, of course, showing a bit of your interest. Because of course, we would be also interested in knowing to what extent we could potentially discuss with other organization on how to, I don't like this word too much, but I think it's quite appropriate to capitalize on the work and make it live and move further as well and explore different dimensions. So I will let you complete this survey, let you some time. So just once again, please, just 2 answers, just limit yourself to 2 answers. It's self-discipline because it's not constraint for the further working areas. We will share all the results, also to say all the presentations, of course, and the takeouts of this scenario workshop that will be sent to you. And we will make also elements public on the PAC website, so you will have all the material that you don't have to take notes. The takeaway will follow up. So I will then, I guess, leave the floor to Jörg while you complete the survey. So please do not think about this survey, and hope to continue this work together to potentially, of course, the PAC project was for 2 years, but we'd be happy also to hear from you and to continue this very this extremely fruitful work, and we believe also interesting for us NGOs, but also for academics, energy experts, and all the stakeholders that have followed this project. So thanks indeed. The poll will be closed in a bit less than 5 minutes, and without further ado, I would leave the floor to Jörg. That would wrap up the workshop and present potential and resume also the potential next step. Thanks indeed.
Yeah, thank you, Jonathan, for this wrapping up. And thanks to all participants for providing your feedback. This is really very valuable for us to learn better how we can improve our own work and how to potentially continue the PAC scenario building process. We saw during this 1.5 hours, 2 hours workshop that it is of course possible and quite promising to deepen on the one hand the research. We had some, I think, really fascinating, very interesting results coming from our 3 guest speakers from science. There is obviously room for improvement of the scenario, be it from a methodological perspective, be it from the scope and other related cross-cutting elements with regards to infrastructure needs, also with regards to maybe even more fine-tuning of certain sustainability criteria. But in the end, when I look also into the polls and into the questions, Jonathan and me, we did roughly 40 presentations of the PAC scenario on different stages during the last 3-4 months. Often, of course, we also had the impression we do not only need to deepen the research, but it's also about disseminating the results and yeah, helping to improve this capacity building, this kind of internal discussion in our network with EEB members, CAN Europe members, together with partners from science. So in that regard, I see a bit the double phase of this exercise, the 2 Ds, to deepen and to disseminate. We are discussing internally, indeed, actually, how to continue with this project. We will keep you posted. And as I mentioned already previously, for members, there is an opportunity for CAN Europe members during our annual General Assembly to dig deeper into the recently launched project, the 1.5-degree Pathways project with climate analytics, which also deserves a lot of attention. And we hope that we can continue this very fruitful cooperation with you on this platform in this regard. We will keep you posted. We still have a few moments if there are any further questions. I mean, Jonathan, just let me know if there is anything more to be reflected from the chat box or from the Q&A session. I then just would like to close if there is no further need to discuss or to check. And we will send out, as Jonathan mentioned, a kind of summary and the notes, the minutes of this workshop, together with a documentation of the presentations and the recorded session.
So thanks indeed, Jörg. I mean, on my side, I can of course repeat the thanks. I will also allow myself to thanks also the logistics, Martina, who has been helping us on logistics to set this event right. I hope that you enjoyed the formats and the presentations, and of course we will for sure follow up. Jörg, I guess that our contact details and the PAC website are now available, so we can indeed, you can of course join and have a look, or a second look, or a third look at the PAC results and revert to us to discuss it. So it's, as I said, to be continued, hopefully. And thanks a lot for your attention. We'll follow up for the next steps. Thanks. And have a nice day, of course.
Have a nice day, and looking forward to see you in the real world maybe next year. Stay safe.